Let us look at proposition number 25 of book 11 of Euclid's Elements. The proposition says, if a parallelepipedal solid is cut by a plane parallel to the opposite planes, then the base is to the base as the solid is to the solid. So let's see how we can prove this. So first, let's cut this parallelepiped using a plane. FG, plane FG cuts this parallelepiped at some point parallel to these two opposite planes. So this could be cut anywhere. What the proposition is saying, that if we take AEFV as the base and EHCF as the base, then the ratio between AEFV and EHCF will be the same as the ratio between the solid ABFU and solid EGCD. So we have to show that base is to base is equal to the solid is to the solid. So let's do some coloring work. Now what we do is we produce AH in both the directions. Now we cut this straight line on the side of AB equal to AE. So let's do that. KL. So here KA is equal to LK is equal to AE. Now we repeat the process on this side as well. So now we have HM is equal to MN is equal to EH. Again, let me move this so that you understand. Now we complete the parallelograms and we complete the solid. So let me complete it. Now that we have done that, let's prove that statement, that base is to the base as solid is to the solid. Now here, parallelogram LP is equal to parallelogram KB is equal to the parallelogram AF. Because remember, the figures between the same parallel lines and on equal basis are proportional to each other. So when we say figure, we saw previously, we were talking of two-dimensional figures. Since these bases are equal, that means these parallelograms are also equal. Similarly, parallelogram KO is equal to parallelogram KB is equal to parallelogram AG. Again, parallelogram LX is equal to parallelogram KQ is equal to parallelogram AR. So we have shown that three faces of these solids are equal to each other, and the remaining faces are parallel to these faces. So that means they are also equal and parallelogramic. Similarly, on this side also, we can show that parallelogram EC is equal to parallelogram HW is equal to parallelogram MS. Parallelogram HG is equal to parallelogram HI is equal to parallelogram IN. Again, figures on the equal basis and between the same parallel lines are parallel to each other. So you have to remember, we are looking at it from a two-dimensional perspective. And again, parallelogram DH is equal to parallelogram MY is equal to parallelogram NT. The same reasoning. So which means since we have shown on this side three faces of these solids are equal to each other, that means the opposite faces are also equal to each other. So that means the solids are equal to each other. Solid ED is equal to solid DM is equal to solid MT. So what it boils down to is these three solids are equal to each other. These three solids are equal to each other. We have solid Lu, the combined solid, is 3 times the solid Au, and parallelogram LF is equal to 3 times parallelogram AF. So, which means solid Lu is to solid Au as base LF is to base AF. And similarly, solid Nu is to solid Hu as base NF is to base FH. And we can make these proportions because Lu and LF are equimultiples of Au and AF. Similarly, Nu and NF are equimultiples of Hu and HF. Now, LF is greater than NF, then Lu is greater than Nu. If LF is less than NF, then Lu is less than Nu. And if LF and NF are equal, then Lu and Nu are equal. Basically, that's what is the definition of proportionality. So, which means we can say base AF is to base FH is equal to solid Au is to solid Hu. So we have shown that if a parallelepipedal solid is cut by a plane parallel to the opposite planes, the base is to the base as solid is to the solid. So that was proposition number 25 of book 11 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.